Today we're doing section 2.5. It is about if-then statements and deductive reasoning. We are going to be using if-then statements and the laws of logic. Here are the warm-ups. On numbers 1 and 2, we are just deciding if they are adjacent or non-adjacent. Anaya, what do you think on number 1? Are those angles adjacent or non-adjacent? They are non-adjacent. And on number 2, Jakai, what do you think? Adjacent or non-adjacent? Those are adjacent. All right, at the bottom, we are finding the measure of a supplement of the given angle. Supplement meaning they have to add up to 180. Kiatha, what would be the supplement of 67 degrees? So as we painfully demonstrated, in order to find the supplements, we take 180 minus the degree we've been given to get our answer. Same thing was done over here, less painfully. All right, our vocab statements for today. If-then statements. Simply a two-part statement with if as the hypothesis and then as the conclusion. So, in case that's not clear enough, the hypothesis is the first part of an if-then statement. The conclusion is the final part. We do not include the if and the then when we identify those. So we'll be doing more examples of this, but the hypothesis, and this example would be, it is cold. So I circled the hypothesis. The conclusion, I will underline, is I will wear my coat. The if and the then are not part of the hypothesis or the conclusion. Finally, deductive reasoning is what we will be using today. Facts, definitions, accepted properties, and laws of logic to make a logical argument. We already did a small example of this on the last page. We are just identifying the hypothesis and the conclusion. Yes, we are going to be writing them out. The hypothesis is what comes after the if, the first part of the statement. So in this case, the hypothesis is, I passed the driving test. The conclusion is what comes after the then, the second part of the statement. So in this case, our conclusion is, I will get my driver's license. On the next set of examples, we are rewriting these as if-then statements. So we have a statement, every duck on the pond is hungry. We have to rewrite that starting with an if and then also having a then. So if this were to be an if-then statement, it would read, if a duck is on the pond, then what do I know about it? It's hungry. Then it's hungry. B. One more time. I think you might have them backwards a little. Jordan, what do you think?
If it does not solve
Okay, I like that one a little better. If it does not snow, then I will go running. For part C, we would rewrite that as if the CD is less than $15, then I will buy it. The law of detachment is going to seem kind of like a well, duh type of statement. If the hypothesis or the first part of a true if-then statement is true, then the conclusion is also true. Okay. In most cases, that's going to make sense. Sometimes we'll see cases where that is not the case. The law of syllogism is a little bit more intricate. So it involves 3 different if-then statements. We take the conclusion from the first one. That becomes the hypothesis of the second statement. When that happens, we can basically cut out the middle. We can cut out that statement about Q, whatever that statement is, and we just jump straight from the first statement to the last one. That's what this final line says. If statement P, then statement R. Again, it makes more sense when we see it with actual statements, not just P's, Q's, and R's. All right, on number 3, use the law of detachment to make a conclusion. So our statement is, if you wash the cotton t-shirt in hot water, then it will shrink. We are told that we wash the cotton t-shirt in hot water. So what do we think our conclusion is going to be? It will shrink. The t-shirt will shrink, or it will shrink. On B, if x has a value of 7, then 2x minus 3 has a value of 11. And we are told the value of x is 7. What can we conclude? 2x minus 3 has a value of 11. Or we could just simply write 2x minus 3 equals 11. That is also acceptable. All right, on example 4, we're using the law of syllogism to make a conclusion. So these are the ones where we're given 2 if-then statements. We have to come up with a third if-then statement from them. If Sarah saves enough money, then she can buy a concert ticket. I should say buy. If she can buy a concert ticket, then she can see her favorite band. So notice that we have part of it that's the same in both of them. She can buy a concert ticket. She can buy a concert ticket. So we are going to cut out the part that's the same. The buying the concert ticket part was the same in both. So our statement's going to be a hybrid of the first statement and the second statement. If Sarah saves enough money, then she can see her favorite band. On part B, we have if the daily high temperature is 32 degrees Fahrenheit or less, then the pipe will break. If two angles are vertical angles, then they are congruent. Angle 1 and angle 2 are congruent, so angle 1 and 2 are vertical angles. The other option is if two angles are vertical angles, then they are congruent. Angle 1 and 2 are vertical angles, so they are congruent. Which one of those is true, Jordan? So are all angles that are congruent vertical? So that's what this one's saying, that if they're congruent, they must be vertical. Is that always the case? No, we can have congruent angles that are not vertical. So in this case, B is the one that would hold up. So we have to choose one and then explain it. So our explanation would be that just because angles are congruent does not mean that they have to be vertical. But vertical angles must be congruent. All right, on this one, if two angles form a linear pair, then they are supplementary. It's our if-then statement. Angles 3 and 4 form a linear pair, so the angles are supplementary. Our other option is, if two angles form a linear pair, then they are supplementary. Angle 3 and angle 4 are supplementary, so the angles form a linear pair. Very similar to the last one. If it's a linear pair, they have to be supplementary. Two angles form a linear pair. They must be supplementary. If two angles form a linear pair, they must be supplementary. But not all supplementary angles are linear pairs.